You know, we often ask, how did our universe begin? It's a huge question, right? But there's an even bigger one that really pushes science to its absolute limits.
Yeah, what was here before there was even a here? For centuries, that question was purely for philosophers. But now physicists are on the case. So let's dive in, unpack the clues, and explore some of the incredible theories they've come up with.
Okay, so our cosmic detective story really kicks off in the 20th century with a discovery that just completely changed everything we thought we knew about the universe.
So picture this. It's the 1920s. An astronomer named Edwin Hubble is up on Mount Wilson in California. He's pointing his telescope at these things everyone thought were just distant clouds of gas. But turns out they weren't clouds at all. They were entire galaxies, millions of them. And then Hubble noticed something truly mind-blowing. Every single one of them was moving away from us. That could only mean one thing. The entire universe is expanding. And hey, if it's expanding now, what happens if you rewind the clock? Well, logically, everything, all of space, all of time, must have started from one single incredibly dense point.
And that single point? Well, that became the foundation for probably the most famous origin story of all time. We're talking about our prime suspect in this whole cosmic mystery, the Big Bang.
This starting point has a name, the cosmic singularity. Now, try to wrap your head around this. Imagine everything you see in the night sky, every star, every planet, our entire galaxy, all the galaxies, crushed down into a single point of infinite density and unbelievable heat. A state so extreme that the very concepts of when and where, they just didn't exist yet. And from that singularity, boom, the bang, an absolutely incredible outburst of energy that literally created time and space as we know it. In those first moments, the universe was just this super hot soup of tiny particles called quarks. But as this cosmic broth started to cool down, gravity began to work its magic. It started pulling those quarks together to form the first atoms. Then those atoms formed molecules. And then, after millions of years, those molecules clumped together to form the very first stars.
So, for a long time, that was pretty much the story. Case closed, right? It seems solid. But then, a physicist named Alan Guth came along and noticed a problem. And it was a big one. The evidence we were seeing didn't quite match the theory. The universe, as it turns out, was, well, it was a little too perfect.
You see, the name Big Bang is actually kind of misleading. It makes you think of a messy explosion, right? Like if you pop a balloon filled with paint, it's going to splatter everywhere, totally chaotic and uneven. So you'd expect the early universe to be like that, lumpy and random. But here's the thing. When we look at the oldest light in the universe, the leftover heat from the Big Bang, it's shockingly smooth. It's incredibly uniform in all directions. It's less like a paint splatter and more like a perfect, evenly expanding red dot. So, how is that even possible?
This whole evenness problem was a major hole in the theory. The original Big Bang just couldn't explain it. But Alan Guth, the same guy who spotted the problem, came up with a brilliant fix, a new piece of the puzzle that made it all make sense.
Guth called it the theory of inflation. He figured that in the very first fraction of a second, some mysterious, powerful force gave the universe this massive, hyper-fast push. This inflation would have smoothed everything out instantly, spreading all that matter and energy out perfectly evenly before the normal expansion took over. And you know what? The idea was a huge success. Today, this inflationary Big Bang is the standard model. It's the story you'll find in most textbooks.
But standard model doesn't mean the case is closed, not by a long shot. For a lot of physicists, the idea of a single beginning popping into existence from absolute nothing, it doesn't quite sit right, and their questions have led them to some much more radical, frankly mind-bending theories.
I mean, think about it. Physicists like Martin Bojuwald look at that singularity and basically say, hold on a second. How can something infinitely dense and hot just appear out of absolute nothing? To them, that's not an answer. That's a missing piece of the puzzle. They argue it had to have come from somewhere. And that's where you get the Big Bounce theory. The idea here is that our universe isn't a one-off event. Instead, it's just one chapter in an endless cyclical story. A universe expands from a bang. It lives for billions of years, and then eventually, gravity pulls everything back together into a big crunch. And that crunch, it rebounds, triggering the next Big Bang. So in this model, nothing is ever really created or destroyed. It's just recycled, over and over again. It kind of implies a sort of cosmic immortality, where the end of one universe is just the beginning of the next.
Now, for this theory to work, you have to completely rethink how you view time itself. We experience time as this smooth, continuous flow, right? Like a pendulum swinging back and forth. But down at the quantum level, time might actually be different. It might be more like the second hand on a clock, moving forward in tiny, distinct ticks. And if that's the case, then the end of one tick, one whole universe, could just be the pause before the beginning of the next one. Okay, so if you thought the Big Bounce was a little out there, buckle up. Let's talk about an even stranger idea from physicists Neil Turek and Paul Steinhardt. They think we need to look for answers outside our universe entirely. Their idea is called brane collision theory, and brane is short for membrane. The theory basically says that our entire three-dimensional universe is just a surface, a membrane, floating in a higher fourth dimension. So, in this model, our universe is just one of these branes floating around, and there's another one floating parallel to us. Over trillions of years, these two branes drift closer and closer until they collide. And that collision? That's the Big Bang. It sparks the creation of not one, but two new expanding universes. Oh, and remember that mysterious force we needed for inflation? Well, a collision of this magnitude could provide exactly that kind of massive jolt of energy.
Now, as you can probably guess, an idea this wild was met with a lot of skepticism. But Turok and Steinhardt make a really good point. Scientists are just people. They can be afraid of change, afraid of the unknown. And it's genuinely scary to question everything you thought you believed in. I mean, people used to refuse to believe the Earth was round. Heck, a lot of people were totally outraged by the Big Bang Theory when it first came out. Sometimes, progress means you have to challenge the comfortable, accepted view.
So, where does all this leave us in our cosmic investigation? Well, we have our standard model, the inflationary Big Bang. And then we have these compelling and, yeah, pretty strange alternative suspects. The bottom line is, the case of the universe's origin is still very much wide open.
The truth is, as of right now, with all the evidence we've managed to gather, we can't definitively prove or disprove any of these three major theories. At this particular moment in our scientific journey, they are all very much on the table.
So let's do a quick recap of the lineup. First, you've got the inflationary Big Bang. That's our standard model, a single, unique beginning. Then there's the Big Bounce, a leading alternative that suggests an endless cycle of cosmic death and rebirth. And finally, the brane collision theory, a truly radical idea that our Big Bang was just one of many, sparked by a collision in a whole other dimension.
We just don't have the final answer yet. And honestly, we might not have it for a long, long time. The only thing we know for sure is that the clues are out there, scattered across the cosmos, just waiting for us to find them. So, as this incredible quest continues, I guess the only question left is, which story makes the most sense to you?